Dear students, welcome to Make Revision Guru channel. The aim of this channel is categorize the problems in GATE exams and the formula used to solve the GATE exam problems. The first part of the strength of materials is the complex stress problems which involves principal stresses and Mohs circles related problems. If you look at it, look at this table, the input part, principal stress, normal stress, shear stress, failure theories, and the standard formulas involved solving these complex stress problems are given here. Then the output is again normal stress, principal stress, radius of this Mohs circle, and failure stress, which involves yield stress and factor of safety. Now we will discuss how to use these formulas for solving the GATE exam problems. In case 1, the state of stress at a point under plane stress condition is sigma x, sigma y and tau xy is given. This 3 input is given. The output is radius of Mohs circle. The second problem, they gave 3 inputs. Then output is the maximum shear stress. The difference between these two problems are, first question they asked the radius of Mohs circle. The second problem is asked the maximum shear stress. The radius of the Mohs circle is nothing but a maximum shear stress. So the one formula is sigma x minus sigma y divided by 2 whole square plus tau x square, and square root of both the things we will get the radius or maximum shear stress involved in the Mohs circle. So this is the Mohs circle. The radius of this Mohs circle is nothing but, this is the formula used to find out the radius of the Mohs circle. Case 2, the state of stress at a point is given by sigma x, sigma y and tau xy. Here also 3 stresses are given. They are asking the maximum tensile stress. Maximum tensile stress is nothing but maximum principal stress at a point. Here the formula is tau x plus tau y divided by 2. This is the average stress we can say. Then this is the maximum shear stress. Combined together, we will call it as a maximum principal. Look at the Mohs circle. The maximum principal stress sigma 1 is by using this formula. The plus sign indicates the maximum principal stress. Sigma 2 is the minimum principal stress. The minus sign we have to use for finding the minimum principal stress. Next, case 3, solid circular shaft of diameter 100 mm is subjected to an axial stress 50 megapascal. It is further subjected to a torque 10 kN meter. Here one important thing is, they are asking the maximum principal stress, but they are not giving the shear stress involved in the shaft. Instead, they are giving the load condition. The load condition in this particular problem is the torque. From the torque, we need to find out the shear stress involved in the shaft. Then we have to use the shear stress in the formula for determining the maximum principal stress. So one thing you need to understand, all the time normal stress and the shear stress is not given in the problem. There is a possibilities they will give the load condition. From there we have to determine the stresses involved in the problem. Okay. In case 4, in a metal forming operations, when the material has just started yielding, the principal stresses are sigma 1, sigma 2 and sigma 3. All 3 sigmas are given here. Following von Mises criterion, the yield stress is dash megapascal. The very important thing is, so far whatever we are seen is the Mohs circle related problems, but in this case principal stresses are given as an input, and also they gave a failure theory. Which failure theory you have to adopt for this particular problem to find out the yield stress according to the failure theory. In a von Mises criteria, there are two formulas are there. The first formula shows the two plane principal stresses. The second one is the triaxial, three planes are there. For three planes are there are three principal stresses are there. In our case is a three principal stress problem. Use the second formula to determine the yield stress. Here n is the factor of safety. You assume factor of safety is equal to 1. Then determine the yield stress for this particular problems. The case 5 problem, here also three principal stresses are given. There I also given the yield stress. Then what is the failure stress theory? The output is factor of safety. That means in this case there are three principal stresses are given. Whenever the three principal stresses are given, we have to use the second formula. In this case, maximum principal stress and minimum principal stress difference divided by 2 is equal to 0.5 yield stress divided by factor of safety. In this case, yield stress is given, maximum principal stress we know, minimum principal stress we know. Only thing we have to find out the factor of safety. So, using maximum principal stress theories, finding the factor of safety, this is the formula. In case 6, it's an interesting problem. In this problem, they gave three principal stresses and also they gave the yield stress 200 megapascal. 200 megapascal they gave. 200 megapascal they gave. They are asking the relationship between the factor of safety in maximum shear stress theory and von Mises theory. Okay. Now we have to find out factor of safety of the maximum shear stress theory NT and determine the NV factor of safety using von Mises theory. Then find out the relationship which is given in the answer. So this is the formula used to determine the factor of safety for the two stress theories. One is maximum shear stress and maximum distortion energy theories. So ultimately, this is a consolidated table which gives the inputs. If they ask the principal stresses, then output will be the normal stresses or failure stresses or factor of safeties. If they give the normal stresses, they will ask principal stresses. They gave the failure theories to determine the factor of safeties. So this is the important formulas. This formula we need to keep in mind before going to the GATE exams. By using these formulas, 90% of the complex stress problems will be solved easily and quickly. Thank you for listening. So subscribe to this video to get the future videos in a similar line for other chapters in the strength of materials. Thank you.